Hello, and welcome to a video about the real-world asset framework on the peaq network. So recently we have updated our documentation to include how the RWA framework is working on the peaq network. So we have it right here in this section underneath the advanced operations. So we have a helpful flow diagram here. We talk about the different frameworks used. And then we also have the contract addresses of the smart contracts that have been used to deploy. So on peaq, we have them listed there, and then same with agung. So for example, if we were to go to, just take that address and put it on our peaq scan, we will be able to see that it is in fact actually there. And you can see that it did execute a transfer ownership execution. So if you would like, you can go and check out all the contracts there. They're listed right there for your benefit. And then further in this documentation, we have a little more information describing exactly how this works on our network. So we talk about the different core modules the SDK offers. So we have onchain ID module, machine NFT module, contract NFT module, etc., etc. And this goes into pretty good detail about what exactly is going on. And then finally, we have the different roles and responsibilities for those who are interested in joining this framework that we go over as well. Okay, sweet. So that's all fine and dandy, but now let's actually get into the meat of things, and that is from the SDK itself that we have deployed. So essentially what this SDK does, it's a wrapper that abstracts away the complex smart contract calls that are done in this framework. So today I'm going to show how to install it from npm and then how to actually interact with it with a real framework. So this is all going to be done on our test network agung because that allows me to have complete authority, so I'm able to execute all of these different operations. Okay, fantastic. So first things first, you would want to go to this page for installation and initialization. And I'm going to do it in JS today. So I can go here, and then I'm just going to set up my environment here. So I can initialize there. Let me just make this a tad bigger so it's a little easier to see. Okay. And then I'm going to install the package and .env. Okay, that's good. And now here I'm going to create the source file where I'm going to paste the code in. And then this next section tells you to create a .env file, and this is very important because this is where all the different roles are going to be defined in combination with what is set in our SDK reference examples. So, there's a bunch of different authorities here where it requires a bunch of different private keys. So it is key that you get this correct about all these different parties and what you particularly have responsibility for. So again, as I mentioned earlier, I set this up on our test network where my wallets have all the authority. So I have all of these set appropriately already in my .env file. I'm not going to show you it, of course, but yes, these are set up correctly. And then if you are like in a GitHub repository, we kind of just remind you want to add that .env to your gitignore. Okay, cool. And then it tells you how to start the code. So I'm just going to clear and then paste that for later. All right, and then this is kind of the initializer function. So here is our init, and we're going to do agung, so that's why the chain is agung. And if you wanted to do peaq, you just simply change that to peaq. But I'm going to be doing ESM JavaScript. I'm going to paste that and then enter. And here we can see we get the SDK back, the module with all the different modules that you can interact with. And then you get all of the different addresses as well, so you can reference them and chain ID. Cool. Okay, so that is us installing and initializing the SDK. And now let's go through the common flow workflow. Okay, so in the RWA framework, there's a bunch of different things that need to happen in order to set everything up correctly. The first thing we already did off screen, which is deploy the framework, where we set up different verifiers, the implementation authority, the claim issuers, the machine issuer, the machine regulator, all of that good stuff. But now we're going to kind of show like what a common workflow would be for this SDK. So the first thing we would do is onboard participants. So we're going to create on-chain ID identities for Alice, Bob, and Charlie. So these are going to be the people that are interacting with the framework. Bob and Charlie are going to receive tokens from Alice. Alice is going to take a machine NFT and tokenize it along with a contract NFT, and then give some of those shares to Bob and Charlie. And then the asset sides, as I said, machine NFT and a multi-party contract NFT, and then a vault and token. Admin creates a vault with Alice as the controller, unpauses the security token, then registers Alice, Bob, and Charlie in that vault's identity registry. So not only they need to be added to the identity registry of the on-chain ID framework on peaq, but then if they want to accept that certain vault, they need to be added to that vault registry on the actual specific vault. And then collateralize and mint. Alice approves the vault to move her machine NFT and contract NFT, deposits them in the vault, and then mints the security tokens. So that's kind of the bread and butter we're going to show. And then finally, the transfer and yield. So Alice will transfer the token to Bob and Charlie, and then she will deposit yield that they can collect as well. Okay, and then I talk about the importance of the environmental variables right here, because that's how we reference everything, and it's key to understand that, or else you'll be interacting with an SDK that doesn't seem to work, but it does quite well. It's just very protected with authority and the smart contracts that are inside of it. All right, again, we list the environmental variables, and here we go into more depth about each one and what they do. I'm not going to talk about that right now. You can do that in your own time. What I want to do is show this full flow right here, right now. Okay, great. So this is that flow that I just briefly described, where we're going to create identities first and foremost using the SDK and the deployed framework. So we can click on this right here, and this lists our SDK reference, which we have a bunch of different functions about everything it offers. So yeah, I'm not going to go into every single detail here. Again, you can do that in your own time, but I am going to copy everything over and test it one by one to show you it working. Okay, so let me just reference MetaMask quick so I can show you the different parties I have. So this account 1 right here, this is my implementation authority, the person who has ultimate authoritative control. And then here I have Alice, who has some AGUN because she's going to be minting the NFTs, as well as Bob and Charlie. And everyone needs to have native token because they are going to need to add claims to their own identity, which comes from their wallet. Okay. So, cool. Got that set up. So the first thing we have to do is create an identity for Alice. So that's what we're doing right here, where we get Alice's public address, and we add it to the subject of the create identity. And then the signer is the ID factory admin. So that is our authoritative wallet, this account 1 right here. Okay, so I can do that script again, node source index.js. And this is going and executing the transaction, which takes a little longer on our test network, but it is creating that on-chain identity for Alice. And here's our result. So we get that receipt, that EVM receipt, and then here we have a little bit of metadata information where we get that identity contract back, and then we get the status. So remember, this is important. We have to do it for all the participants. So we have to do it for Bob and Charlie now. So I'm going to change this to Bob, and Bob, save it, rerun it, and do the same thing with Charlie. And then remember that they are referencing those accounts right there. Okay, so I got one for Bob, and now I changed Charlie. And then it is going to create an identity for him as well. And this SDK is wired to Agung, again, with all of the addresses that are linked to my private keys. So in practice, it is a bit difficult to replicate, but once we have architecture built out on peaq, it will be much easier, so you can request certain actions. But this is mainly for proof of concept. All right, so that's great, cool. We have our identities for all of these different people. And now we need to add KYC claims to these identities. And this essentially says, all right, these are real people. And we have a function for that as well that I can copy and paste. And again, I'm going to need to do this for Alice, Bob, and Charlie. So we have the claim issuer, and this was used during deployment, where the claim issuer has the KYC property, where they are the entity that is able to give out KYCs. That's how we had it set up during our deployment. And then we get Alice's address that we need to attach. So this issue KYC claim, the claim issuer signs this information to generate a claim and signature. And then Alice must send this from her wallet. Going to that identity contract we just created, we're adding that claim that was issued from the claim issuer to that identity contract. So we can run it. And then I'm going to, as that's running, I'm going to change this to Bob, because again, we need to do that to all. Let's just change that to Bob. And then Bob. Bobby. Bob. Okay. Cool. And then here we got information back. We got it added with that claim ID. Don't need to save that. I mean, you could, but right now I don't. Charlie. And then I'm going to change this to Charlie. Okay. Save all that. Got added for Bob, and now one more. Alright, it's been added as well. So now each one of these identity contracts we just created, we attached a KYC claim to them from the claim issuer. Alright, so now we need to register machine NFTs for Alice. Before we can do this, we must allow the machine NFT to spend for Alice. So that is what this function does here. So we're going to copy and paste. And this is a preset machine NFT that's already been deployed. So the machine issuer would actually give you that contract address. But for now, this is what I have it set up as. Okay, so it's telling the machine NFT contract, hey, you can spend 20 native token, right? Because machine count is 2 with the value 10. Yeah, so it allows the spending of that token on behalf of Alice. And now let's actually register the machine here. And we can copy that, paste it. Okay, and again, we have that same machine NFT. But this must be executed by the machine issuer, essentially saying, hey, I'm going to allow Alice to control these two NFTs that we want to, these two machines that we want to fractionalize. So for now, I'm just doing 2, and they're 10 each, 10 peaq each, and then they cost 10 peaq. And then we have to set the token decimals as well, and for peaq it's 18. All right, and then this has to be executed by the machine issuer. And then we connect Alice to be the controller. So yeah, and then we can run this as well. Okay, it is executing. Sweet. So this is a bunch of information we get back here. So we see that it's issued that machine NFT with that machine issuer for the controller. We see the machine value, how much it's costed each, and we got 2 of them. And then here we have machine IDs along with their DIDs. And then if you want, you can go in and actually see the receipt. But for now, what we really want is we really want to save those machine IDs because we will need them later. So got that one and got that one. Okay, cool. And then also in the background, we created a DID document for the different machines too. Okay, cool. So that's done. We registered the machine where we fractionalize it into 2 different pieces being 10 peaq each. Okay, so now we have the machine NFTs, and we're going to create a hypothetical contract NFT, essentially binding Alice, Bob, and Charlie together to say that like Alice is the owner and then Bob and Charlie are able to own the token as well. So again, we have sample code that we can execute this on. Paste it there. So this first step here is actually creating the contract. So again, we have a preset contract NFT that we can reference, and then you could reference it to an actual live URL and then hash it. So this is the create contract function where we have the contract controller as Alice. And then we have counterparties as well. So we create the contract, but then we also need Bob and Charlie to sign it in order for it to be completed. And then we link up the hash, the NFT, and the URL. So I can execute this too. And then we should get our contract ID back that I want to save as well. Okay, we get that receipt, we get the fee, content, but here's what I want. I want that contract ID. Paste it there. We'll use that in a second. So the contract's been created, but now we need Bob and Alice to sign it. And since I have all of the keys, I can do that on behalf of them. So I'm going to paste that into there. So we have kind of that sign contract function. And that's why I need that contract ID, because we reference it directly. Yep, and we have Bob, private key, and then we send it through Bob. Okay. So we can do that, and then I'm going to change this to Charlie while that's running. Okay, I guess I didn't want to do that. There. All right, and then we can see the progress here. We have 2 signatures out of 3. Alice pre-signs it when they create the contract, and then Bob just did. You can see it's signed, that contract ID by that signer. And then I just added Charlie, so we can execute that as well. Okay, and we now got the status as completed. Sweet, fantastic, that contract is good to go. Alright, so now we need to actually create the vault, and the vault deployer is the implementation authority in this situation, and they set Alice as the vault controller. So here is where we actually kind of set up our security token. Okay, so we have our vault controller here, Alice, where we actually don't need their private key. I can update that later, but we don't need their private key here. We just need their address, because that is what is set as a vault controller, but we do need the vault deployer admin, which is our admin private key here. Okay, and the vault factory and info desk, these are both preset values that we have in the deployed, already set in the deployment. So that's good to go. And yeah, so essentially this is going to create a token of test token ABC with token symbol ABC, which represent the fractionalization of those machines we just registered along with that contract NFT. Okay, so I can execute this. And then after creating the vault, it's going to give us the vault back, the vault address back, the security or the token address back, and then the distributor. So this is all helpful information we will need later on, which I'm going to save here. Okay, cool. We can clear that. All right, so now we have our vault created. And then after doing that, we need to unpause the token so it's able to be transferred. So we have our vault factory. Again, that's the same thing that was set here. Oh, okay, wait. They aren't lining up. I think I know why. Let me just see real quick what I have as, what is set in this A-gung. Boom, 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 boom. Vault factory. Okay, so it's the 6B one. Sorry about that, guys. So vault factory I have here as this. So I'm gonna need to update that there. And then I hope that info desk is correct. Let me just real quickly check. I need to open this. And then info desk. It was F2. Okay. Okay, that was just, I forgot to wire up the docs to be that. But we're good now. So I'm going to have to redo that vault again so I can hook up the proper vault factory and info desk. Okay, so same exact thing here. And then I'm going to get new values back for this. So I can just erase that. Sorry about that little hiccup, but we should be good to go. And then we didn't see a failure right away, but we would have later down the line. So I'm glad I checked that. Okay, so we're gonna copy that, paste it, token, comment that out. All right, cool. So now what we can do is we can go back to that common flow here, and we were unpausing the token. So I can copy that, paste it, and now we have that vault factory that actually corresponds correctly to what we have set. And then this vault we would need to change to what we just created. And this is by that vault deployer, the implementation authority. All right, unpausing the token. Cool, unpaused. And now we need to register all the different identities for Alice, Bob, and Charlie in this vault identity registry so they can accept it, the token. So we're going to be doing that. We need to update the vault again there. And then we can execute. So first one for Alice, and then we're going to have to change this to Bob. Okay. All right, registered Alice. Now registering Bob. Okay, great. Bob's been registered, and now finally Charlie. Okay, cool. So all of those identities have been registered to that vault, so now they're able to actually accept the token. And now here we have the deposit and mint function, which is going to mint that security token to Alice. So the vault, we need a copy here, and then this is why we kind of needed to have those token IDs here, because we need to set them accordingly. So those are the two machine NFTs that correspond to those addresses, and then here's the contract NFT that we connect here as well. Okay, so the vault controller, remember, is Alice, so they need to be the signer here. And if we go to Alice right here, we can see, if I go to our block explorer, we can actually see that they have the two NFTs that we fractionalize, and then also the contract NFT. But now we're going to add the actual tokens in this function right here. Okay. Caller is not token or owner approved. Did I skip something? Yes, okay. So this is actually a nice little error because it shows you how secure this stuff is. But what we forgot to do is we forgot to approve the NFTs to be able to execute this. So that was because I was a little discombobulated from the not setting the vault correctly, but we can fix this. So this was a step I literally just skipped, step 7. Okay, so this approves the NFTs to be able to spend. So first is that machine NFT that we need to do. So we need to update the vault here, and then with the corresponding token IDs here and here, and I believe that's the NFT one. I just want to make sure. Yep. Okay, so this is gonna fix that first error we saw, and then we would also need to do that same thing with the contract NFT. So update the NFT there, and then with that token ID, essentially approving the NFT to spend on behalf of Alice, who is the controller, right? Okay, so we got our information back. You can see what we got, and now we need to do it with the contract NFT. Oh, did I forget to set? Oh, no, that's good. Okay. And then the vault, yep, that's the same, and then token ID is that contract NFT. Okay, approved. Cool. All right, so now we can do this deposit and mint function. So I'm going to copy this, paste it there, and then I need to update that vault again from when we registered the machine. And then these are already correct. They correspond to that machine NFT and then contract NFT. And then what specific ones? Well, that's why we have these token IDs. And then finally this last one here. Okay, so again, it's going to show up as ABC here as a new token, 10,000 of them. All right, cool. It's executing, and it's depositing and minting. Deposited and minted, fantastic, with these RWA NFTs for these token IDs. All right, cool. And it's going to take a couple seconds for it to show up here. So while it is indexing, I'm going to go on to this next step, which is insured transfer fee allowance. So whenever a transfer occurs, an approval has to occur before. So that's what this is. This is essentially saying that Alice can spend 2 of these tokens, can transfer 2 of these tokens. So that's the vault, and then this is the token here, and then the transfer amount we set there. So maybe if you want to like have Alice be able to transfer, the full 10,000, you can just set 10,000 right away. But for now, I'm only going to set to 2. Okay, so I'm going to run that, and that's executing. And then as that's executing, I'm going to refresh this, and then we can see that we now have the new token right here, ABC 10,000, which corresponds to those 2 machine NFTs and contract NFTs as a security token that we're going to be able to transfer to Bob and Charlie. Okay, so we just ensured transfer fee allowance that Alice can do that. Cool. So that's done. And now here we can actually execute the transfer. So after all of that setup, we're able to transfer the token. Again, I'm grabbing these values here from when we registered the machine. And what this is doing is transferring from Alice to Bob. So we're going to execute that there. And then in a new tab here, I'm going to grab Bob's address. Paste it there. Okay, let's see what we got with our logs here. So we got the status is transferred with that token from Alice to Bob. How much? Okay, so if we refresh this, still taking some time to index. And as that's doing that, let's just transfer to Charlie as well. And then from Alice to Charlie. Refresh. Okay, and then we get the transfer status again from Alice to Charlie. Okay, cool. So it just showed us the 2 transfer tokens right away. So we can see when we refresh here, this is Bob's wallet. They have 1 ABC. And now if we go to Charlie, we can see that they have 1 ABC as well. And then, Alice just sent 2 out, so it has 2 less than the 10,000 we started off with. And then we can see transfer right here as well. Okay, cool. And now the final little thing quickly we can show is depositing yield, which we have right here. So we're going to have Alice deposit some yield here that people can claim. So we're going to do it on this vault here. Let's just do 2. Execute it. And then we can claim yield once that's done finishing. Deposited to that vault with the reward distributor. The tokens is peaq native. How much? 2. Cool. So now it's claim. So this is going to be Bob being the claim signer with the vault here, where they get a portion of how much they actually own. So claiming the yield in proportion to how much they actually own of the token. Got it as claimed. Sweet. And then finally we have a claim to function where Alice claims kind of the rest of the yield manually to Charlie here. Okay, cool. And then we can copy Bob's address here. And we can see that they got the proportion of the yield they own. So that's Bob. And then we had, with the claim 2, we had Charlie receive the rest. So we can go here. And then yeah, I'll be updating here because I can see the transferable. But yes, it's just taking a little bit to index, but that would show up there as well for Charlie right here. Okay, cool. Fantastic. So that is the common flow of the RWA framework on the peaq network. So again, this was shown on Agung, which is essentially a copy of peaq network, the test network being Agung, where my wallets did the deployment, so I was able to execute all of these steps myself. And then it was wired to the SDK, so then it was able to call the smart contracts that were created on behalf of it. So kind of the next steps here are to get other parties involved so we can replicate this same instance on peaq. So I hope you liked the video. I hope it was really informative. It was really cool to make and understand this process. So yeah, have a good day. Bye.